Hi, my name is Yohan Shamtob. I'm going to present how I use an autonomous and biomimetic robot to study the collective behavior of zebrafish. Using artificial lure to study animal behavior is something that has been done for a long time. And in our experiment, we are using a robot designed to be integrated in a group of fish. So this robot, as you can see in the video, looks like a fish and moves like a fish. And to move like a fish, it used a stochastic model that is going to build a trajectory in real time according to what the fish around are doing. A previous study has shown that these two aspects, the physical aspect and the behavior, allow the robot to be integrated into the group of zebrafish as if it was a conspecific. I put the link to the article at the bottom of the slide if you're interested. From this base, I tried to find out if it was possible to confirm hypotheses on collective behavior by using this robot. I first focused on reproducing a specific behavior, the leadership. In zebrafish, we know that each fish has the same success rate to lead a collective departure. And we expect that if our robot initiates collective departure, we are going to observe the same kind of dynamic. We also tested if it was possible to modulate the behavior of our fish by reproducing specific behaviors. In this experiment, we tried to bias the distribution of fish in space, and we tested different strategies for that I will explain later. For our experiments, we designed a setup that consists of two rooms connected by a corridor. Typically, in experiments with only fish, they are going to rest in the room and perform collective departure to move from one room to the other, over and over. For the first part of my study, the robot swam with a group of fish, and every time he had the opportunity, he tried to initiate a collective departure by moving from the first room to the second room. For the second part of the study, we try to bias the time that fish spend between the two rooms. Here we're using two different strategies. First, we use the robot as a leader and program it to initiate collective departure in the direction of the target room. The second strategy was to use the robot as an anchor. We program the robot to swim around only in the target room, and we hope that this behavior would delay the departure of the fish to the other room. So here you can see the results for the first experiment. In the first graph, we have the proportion of collective departure initiated by each fish. So A, B, C, D is each group, so each replica. And each square represents a fish, except that here the green square is the robot. So the robot was able to initiate collective departure and actually initiated more collective departures than most of the fish. In the second graph, we have the success rate for each individual to cause a collective departure. And we can see that the robot has the same success rate as the fish. So the first graph represents what we expected because that's how we program the robot. But in the second graph, we see that the fish reacted to the robot in the same way as if it were a fish. So here are the results for the second part of the study, in which we try to bias the time spent between the two rooms. In the control experiment with only fish, we can see that fish have no preference and they spend an equal amount of time in both of the rooms. But when we use the robot to try to initiate a collective movement in the direction of the target room, we see that it has no influence on the time spent by the fish in the room. That can be explained by the fact that our fish only spend a very short amount of time in each room at each time. And even if the robot does initiate a collective departure successfully, it's not going to influence the time spent by the fish in the room. But if we try to use the robot as an anchor, as a shy fish that doesn't want to get out of the room, we can see that we have a bias between the two rooms that is significant. And if we use two robots doing the same thing, moving inside the target room, this bias was amplified. And that is interesting because even though bold and shy behavior have been described in the literature, it is hard in zebrafish to actually observe it. Here, our robot reproduces an amplified version of that behavior, the shy behavior, so we can observe the impact it has on the group and how potentially that behavior can help groups selected a better habitat. The result of all this study highlights the ability to an autonomous and integrated robot to test hypotheses, where many previous studies were based only on observation. I thank you all for listening. If you have questions, you can contact me by email. I'll also include the link for the article on the slide. All this work was done in Paris with the help of the Lausanne team at the EPFL, and it has been funded by the ACC project, an European project working on integrating robots in social group of animals. You can find more data information on the project by following the link. Thank you all. Bye.